Hello everyone, welcome back to the channel about fireproofing dwellings against wildfires. I can't say this enough. Our main objective is to save lives. So today we're going to talk about how to perform standard fire design for fires inside buildings. And we're going to see how we can use these guidelines to promote future exterior fireproof dwellings against wildfires. So just full disclosure statement, I need to say this because some people already asked me this. Our research team has no financial interests in the products of the companies here presented. This research project is not supported by the private construction industry, and this is a non-sponsored video, and all guidelines are technically free for everyone. Okay, so the concept of fire protection design is basically in 3 steps. When you have a fire in a wall, in a structure, in a member, whatever, you basically have to verify 3 things. You have to verify if the fire doesn't promote the collapse of the structure, so we have to verify the resistance of the structure for the fire action. We also have to verify the integrity of the structure, which is this E here. And we also have to verify the insulation. So the difference between the E and the Y is the E is the integrity, which means we must have enough protection for enough minutes in order to not promote any passage of smoke or flames. The insulation is we must make sure that the temperature doesn't get very high on the opposite face of the fire inside the building. Okay, I'm not going to enter in the technical details of this type of fire design, but I'll explain them very briefly. So, as I said, we're going to talk a little bit about the passive fire protection for fires in the interior of the building, and then we're going to extrapolate how we use this for the exterior. So, the structural fire resistance guarantees that there's a stability, a structural stability of the elements in a building, in the case of a fire, according to the standard, European standard. And the fire reaction of the materials is we have to make sure that when the materials are burning, you can actually still breathe inside the building. It's not that simple, but imagine like that. Okay, so these 2 conditions, the fire resistance and the fire reaction, they are governed by the European norms, part 1 and part 2, one related to fire action and the other related to fire resistance, which is EN 13501. Also, sorry, it is maintained. We need to. This is the need for these verifications, the fire reaction and the fire resistance, is to maintain the safety for a limited time to promote the evacuation, basically, of the building. Okay, these are the main conditions that this European standard guarantees. So, as I told you, the R is for the resistance, also known as the load-bearing capacity. The E is for the integrity, which is not related to E, but we still call it integrity. And the Y is for the insulation, according to EN 3501 part 2. For example, this is a small example. Imagine you have a material that you say it's an E60 and EI30. So what this means is you have an integrity for 60 minutes, but you only have an insulation for 30 minutes. Okay, normally as we define them too. A lot of providers, manufacturers only provide the EE30. They don't provide it separately. They normally provide the minimum time of insulation or either integrity many times. Okay. So just to explain a little bit, what's the load bearing capacity? Is associated with the maximum load resistance after a given time, as I explained it before. So imagine you have a fire, you must make sure, for example, just like in this image, like you have a beam, and then the beam may collapse due to the action of the fire with self-load on the middle span, for example. So the ability of the element of construction to withstand fire exposure under specific mechanical actions, of course, and without losing any structural stability. The integrity, as we said before, is associated with the exposed time, with the exposed side letting in the unexposed side either flames or smoke. So the unexposed side must remain its integrity. Okay, it must. So the surface that is not in contact with the fire must not promote the transfer of either smoke or flames from the other surface that is indeed being hit by the fire. Also, this is basically the ability of the element of construction, as I said before, to prevent the passage of flames or hot gases on the exposed side. Insulation. So this is different. This is basically, okay, when you have a fire in a division, you must make sure that the cool division, the other division that doesn't got any fire, must not heat very quickly. So the temperature in the other side of the room must be low. So the unexposed surface, the increased average temperature must be below 140 degrees, okay? Basically, they say 180 degrees at any point. For example, imagine you have like bolts or a small connection. But in any case, we normally look at 140 degrees. So the unexposed surface must not have more than an average temperature of 140 degrees. So what type of curves do we use in these three type of tests, as I told you? Load bearing, integrity, and isolation. So we use a nominal curve, and normally not a real natural fire. So a nominal curve was a curve obtained in the beginning of the century, basically, using a lot of experimental data by other authors. Okay, I'm not going to detail how this was used. This curve is normally used in industrial ovens to do these tests. For example, this is I believe it's in England, this United Kingdom. I mean, this is a specialized furnace to do these type of tests. As you can see, you do like a logarithmic regression or a linear logarithmic regression. You can get literally this type of curve if you use a lot of experimental data from a lot of authors during the beginning of the century. Okay, I'm not going to explain how this was obtained. Okay, but if you want to know how this curve was obtained, I recommend reading this book. This is for me, it's one of the best books that exist. Structural Fire Loads, Theories and Principles from McGroyle. Okay. The author Leo made an astounding work how to essentially make a short presentation, although very complete, about fire engineering and fire safety. Okay, you guys can go to Amazon and buy the book. I truly recommend to do this. This is a very good book to understand how this ISO curve was born. Okay. So, as I said, this ISO curve, which is this one here, does not simulate a natural fire. There are ways to connect the natural fire with the ISO curve, although it's not, how should I say, is not settled by the scientific community, but there's a way to get it. So a natural fire curve is basically a performance-based curve, which is this one here. This is a natural fire curve. And the ISO curve doesn't have, for example, the ignition and the smoldering. Okay, it doesn't have nothing. It just starts with a flashover and it goes until infinity. So it never has the cooling phase. A natural fire normally is hotter than the ISO standard curve for the same time, but then it has the cooling phase. Okay, so the ISO standard curve, the 834, it's a nominal curve. This one here always grows. A natural fire curve is a performance-based curve, and you will see in the future that for wildland fires we have to use performance-based curve and not ISO curves. But for this video we will promote our first fireproof construction guidelines using the knowledge that we know from the ISO standard curve. We will then in the future correct this. So fire reaction. Fire reaction measures the materials, thermal behavior, and how it contributes to the growth of fire. So you basically have your classes A1, A2, to F, in which A1, the product will not burn, literally, for example, rock wool. And then you can have products that show no performance criteria, either E or F. So for example, you may have some type of wood that may be closer to D, but normally wood is around D and F, okay? So these will likely burn, okay? For our fire construction fireproof guidelines, we will recommend something between A and C, okay? And then we have the aero class system that will also rate like the smoke and the dripping. So basically, The smoke can be S1, S2, S3, which is the ability to pass or not smoke during create smoke during the fire reaction test. And then we also have the flaming droplet particles, like you can have some drops and some particles from D0 to D2. I have no idea why they said it D0 and D2 and the others is S1 and S3. I have no idea, but this is how it's written in that norm, that European standard that I told you before. I think it's the EN 501 part 1, if I remember correctly. If I didn't say it correctly, sorry. But basically, if you have D0, you have almost no drops or particles. For example, I believe rock wool is something like this. This is a very also brief presentation table. This is, if I remember correctly, this is also from a construction provider that provides materials, and he has this table organized like this. And for non-combustible materials, as I said before, you must have A. Basically, that's it. A1, maybe A2, but basically A. If you have A1, then you got guaranteed that you will have like no problems with this previous like smoke opacity or flaming droplets or particles. But you can still have good performance instead of fire reaction and still provide a good solution for fireproofing if you have something around C, maybe C, actually B it's better, but C and also S1 and maybe D1. Something we will look, this will be our limit for our fireproof construction guidelines against wildfires, and then we will explain it why. Okay, we will be around this limit, although this one would be the most, how should I say, the most optimized and the most safe. Okay, for example, you have wood is around somewhere around this. Also, some wood may be D, maybe a little bit better, but wood will be around this. That's why you will see in our future videos we do not recommend wood structures for dwellings that are near the wildland urban interface. Okay, because if your structure is made of wood, you can still protect wood, but it will be difficult to run away from this fire reaction classification. Okay. So fire resistance and fire reaction. For example, this is a very good image that explains quite well which is the reaction to fire and fire resistance. So the fire reaction, basically imagine you have a fire and the other division doesn't pass any smoke, doesn't pass any gases, and also for example the fire resistance. The fire resistance doesn't pass any gases, any smoke, so the temperature in the unexposed surfaces doesn't pass that increment of 140 degrees, as I told you. And also the load bearing capacity, imagine like you have like a column here and the column will not collapse. The reaction to fire, imagine like there are so when you have this fire, you must make sure that you have low droplets, low particle production, low smoke production, which is not easy with all type of materials. But this image explains very well how to perform like the fire reaction verification, and here you have the fire resistance verification. Kudos to the author of this picture. So how do we apply this to the thermal behaviors on wildland fire? So a wildfire possesses a maximum temperature around 800 to 900 degrees for 3 to 10 minutes. I'm not saying that a wildfire only endures 3 to 10 minutes. That's not what I'm saying. So the maximum temperature is around 800 to 900 degrees, but this maximum temperature will be around this value for 3 to 10 minutes. And I'm being very generous with the 10 minutes because it normally less. Okay, we already did this study. And then we'll explain in the future that it's even less than 10 minutes. But for our analysis, we will admit this. So its total duration is above the ambient temperature. Its total duration above the ambient temperature is around 30 minutes. So normally if a wildfire passes very quickly when hits a dwelling. So when a wildfire hits a dwelling, it doesn't take much long. So it starts to approach the dwelling, starts to increase the temperature of the dwelling, and after 30 minutes the wildfire is gone. Okay, and the dwelling may burn during those 30 minutes if it's not fireproof in any way. And also, the problem is not only the direct contact of fire, which is the direct action of the wildfire, but also the indirect action of the wildfire. For example, the firebrands. And these firebrands, they do present a maximum contact surface temperature around 400 degrees, maybe a little more. But also these ones are more for 30 minutes, so it's a lower high temperature, but they endure more than 30 minutes. Okay, we're already doing this type of studies, and we can easily guarantee that they would last around even higher than 400 degrees for at least an hour. Okay, don't forget firebrands, firebrand projections. It's the type of wood that when it burns, it starts flying and starts to accumulate in the surface of the dwelling. So it's the firebrand accumulation that presents this high temperature for a long duration of time. So how to apply this to a wildfire? Imagine you have an isolated dwelling. So an isolated dwelling must withstand the 30 minutes associated with the maximum time passage of a wildfire. So we would only need to design the fireproof construction structure for at least 30 minutes if the dwelling is isolated. So this is admitting like might be some fire in the trees, you may have some fire in the bushes, might be some firebrand projection, so 30 minutes is enough. But if your dwelling is near the wildland urban interface, so you can be near another house that is not prepared to be fireproof against wildfires. So your house may endure 30 minutes, but if the house next to you starts burning, then you need more than 30 minutes. So we will admit at least 60 minutes. So our initial fireproof construction guidelines will necessitate at least a resistance of 60 minutes. Okay, not a resistance, but an EY of 60. Okay, we don't put the R there because we're not looking at the resistance of the materials. We're looking more at the integrity and the isolation, because our main objective is for the dwelling not to burn. Also, the envelope of dwelling facade, the fire reaction must be at least B, although we can still consider C, and then we will see why. Okay, this is for the roof. This is a problem for the roof. So C is still admissible, but it must be at least S2 and D0, according, as I told you, to the previous standards, EN 13501 Part 2. Sorry, Part 1. This is a typo here. And EN 1364 Part 3 for exterior walls. Okay, this is according to what we need to verify according to the European standard. Okay, so let's just make a fast resume. So the design guidelines against wildfires is the need for the dwelling to be at least AE for 60 minutes in the exterior facade. This is equivalent to reaching a maximum temperature of 445 degrees according to the ISO standard curve. So remember, we said a wildfire can have a maximum temperature around 800 to 900 degrees in the trees and the bushes, but it's only for 3 to 10 minutes. So if we admit an EY of 60 minutes, we go even for a maximum temperature above 900 degrees, and therefore we guarantee that the dwelling is fireproof against wildfires. The dwelling exterior facade needs to have a fire reaction of at least B or C, as I told you before, and preferably S2 and D0. Okay, once again, sorry for the typo. The European standard is not Part 2 but Part 1 for the fire reaction. So, advantages and disadvantages. Well, taking into account that the wildfire time duration is quite low compared, and even its maximum temperature is quite low compared to the ISO standard curve, these guidelines that we will provide you in the future are clearly conservative. Okay? So, if we follow these design recommendations, I guarantee your dwelling will not burn, although they are conservative, but they are not economical. Okay, and maybe some hard application in the existing of old dwellings that need to be rehabilitated. So in the future, we will present two types of recommendations. We will present an initial recommendation based on the ISO standard curves for wildland fires, which are more conservative. And then we already doing this. We're studying new wildfire standard fire curves for the design fireproof protection of dwellings. And we will present a part 2 recommendations which are more economical. Okay, so from this part of the project, we will present the existing guideline recommendations that are conservative but not economical. Okay, but you can still use them if you are interested in this. Although, as I told you, these are hard to apply in old dwellings because they are very conservative. Well, that's all for today. Hope you guys have enjoyed. Like, subscribe, hit the like button below. If you have anything to say, comment below. And if you guys can, show this video to your friends, because we are trying, as I said, and I'll say it again, the purpose of this channel is to save lives. Okay, that's all for today. See you in the next video.